Hello everyone, today we will study in detail about the PN junction. Now we will see the two biasing concept of PN junction diode. The first one is forward bias and the second one is reverse bias, and we will see the output waveform of this effect of forward bias and reverse bias also. So, what is forward bias? In case of forward bias, the P type is connected to the positive terminal of the voltage source, external voltage source, and N type is connected to the negative terminal of the voltage source, say V in. Now, what will happen? Due to this positive terminal, the positive charge will be developed in this, and due to negative, the negative charge will be developed in this area. So, what will be the effect of this positive charge of this majority charge carrier of P type? Because of the positive charge carrier, this majority charge carrier, that is holes, will be repelled by this charge carrier and they will try to move in this direction. So, all the holes will try to move in this direction. Next, in the same way, the majority charge carrier of N type semiconductor, they will try to move in this direction because of this charge carrier developed at this region. Because due to this charge carrier, all the majority charge carrier, that is electron, will be repelled and they will try to move in this region. So, as a result, there will be a pressure on this depletion region, and depending upon the input voltage, this barrier will be shrinked. Now, if suppose without any bias, we know that a built-in potential is generated in this region, and suppose this built-in potential is about, say, 0.7 volt. Now, suppose input voltage we are giving, that is equals to 0.1 volt. So, by this 0.1 volt, will we get any current from this PN junction diode? The answer is no. Why? Because we are giving the voltage 0.1 in this direction and the voltage developed or electric field developed in this direction, that is equals to 0.7 volt. We are giving 0.1 volt externally and the voltage or electric field generated, that is 0.7 volt. So, if I measure, then the result will be 0.6 in this direction. So, there will be no current because there will be depletion region, and due to that depletion region, no majority charge carrier can flow from P to N or N to P. So, how can we get the current? So, now if our external voltage Vi, when it will dismiss the built-in potential voltage, that means greater than equals to 0.7 volt, then only there will be no depletion region, and for that we will get the current. So, if I now plot the current versus voltage, then we will get, if we try to increase the voltage, say 0 to 0.7, we will not get any current. Why? Because the external voltage cannot dismiss the internal voltage which is developed at this PN junction diode. So, from 0 to 0.7 volt, we will not get any current, but after 0.7 volt, the current will be getting like this. So, this is the graph or waveform for forward bias. Now, in case of reverse bias, what will happen? This is P type again and this is N type. So, P type is connected here with the negative terminal of the external voltage and N is connected with the positive. So, what will happen? Due to the negative, all the negative charge will be created here and positive charge will be created over there. So, due to this negative charge, the majority charge carrier will be attracted and this positive charge will move from there to here. So, this positive charge will move from here to there, and in the same way the negative charge will move in this direction. So, as a result, what will happen? The depletion region cannot be shrinked, it will be wide. So, suppose the area is now D, this one is the D. So, by use of the external voltage, say Vi, the area will be, the distance will be more, because it cannot be shrinked because of this input voltage, the depletion region will be wider. So, as a result, no charge carrier can flow from P to N and N to P. So, we will not get any current. But in this case, in case of P type, the minority charge carrier are electron, and majority in N type, the minority charge carriers are holes. And in this direction, suppose the electric field where negative charge is there, positive charge is there. So, in case of P type, the minority charge carriers are electrons. So if we place electron over there, then the minority charge carrier actually flow from this P to N. In the same way, for N type, the minority charge carriers are hole. So if I place a hole over there, then the hole can move from N to P. So in case of reverse bias, no majority charge carrier can flow from P to N or N to P. The minority charge carrier for N or P type, they can flow from P to N and N to P. So because of the minority charge carrier, we will get the current in case of reverse bias condition. And if I try to plot the graph, then suppose I versus V, the graph will be like this. A small current we will get, that is called saturation current. Why saturation current? Because in terms of majority charge carrier, the number of minority charge carrier is very less, and due to that a small current will be taken or will get across this device, and this is called reverse saturation current and for reverse bias condition. So this is forward bias condition by which we will get the current in this way, and this is reverse bias condition where we will get the current which is very less. Thank you.